I am Mickey. Live from what room? What room is this number? 2119, is it? Oh yeah, there's some sort of thing happening here Saturday as well. So don't leave anything in your desk because it will be whipped. All right. So I don't know what's on here Saturday. Oh yeah, does everyone want a student card?
Yes.
Yeah. So what do we need to do? We need to get a letter from Joan, yeah?
Say the firm course and how long the course is lasting.
Yeah.
Full time.
I don't think we'll put on how long it's lasting.
No, just
How did you get a student card? We need to go to NUI, is it, Brian? Is it?
Yeah.
Oh, it's online, is it?
You need photographs as well, yeah?
Yeah. It's online, is it?
Yeah.
Send me on a link for Brian and I'll make it available to everyone, all right?
Yeah.
And you just go into NUI Galway then and fill it out. Or bring it into them and NUI Galway, is it? Great. Right, so Jason, do you want a student card?
Right. Do I want a student card?
Yeah.
Yeah, sure. Yeah.
Yeah, well, you get loads of stuff.
But when's it valid till? I might until we finish here.
Well, you don't tell them when they're finished and you just, you say nothing. All right? I find the less information you give, the better in these cases.
Yeah. Well, there's a thing date on it, isn't
Huh?
There's a use by date on it.
There is, but it's usually a year.
Yeah.
So you should get it at the end of the year anyway. So, right. I'll send it to her this evening, the email, okay? Because if I send it now, she might come back at around 3:15 and wouldn't be able to leave, didn't I? So I'll send it as I'm going out the door. Is that okay? So we need a letter for student card. And you should have those tomorrow evening, so you can. Oh, you won't be able to apply tomorrow evening, sure. I'll get the letters by tomorrow evening. Anyway, so we're starting. Right. So I don't want to stop. No. Now, these are basically thread-safe versions of all the sets, maps, and queues. Okay. Now, that is the thread-safe version of a hash map. That is the thread-safe version of a deck. That is the thread-safe version of a queue. Believe it or not, we didn't do any queues. We did decks, which is a subclass of queues, but we didn't do any queues. That one, now, that's frozen. Now,
So were those atomics? They were just for primitives there?
no, they're for, you can have an atomic, you see, that's the thing. You can have an atomic array list as well. All right. Now, I don't know how atomic array lists work or atomic sets work. I'm not too sure. All right. But what you have there is an atomic reference to a non-thread safe object. Do you get me?
Yes.
So I'm not too sure.
Which would then just make it thread.
Yeah. Okay. Now, this guy here, concordant skip list map and concordant skip list set, that is a thread safe tree map. That is a thread safe tree set. So whatever you put in those has to implement the comparable interface or has to have a comparator for it. Now, copy on write array lists, copy on write array set. All right. Now, this is the closest version to an array list, a thread safe and array list. Now, these two guys are different to all the rest of them. Okay, they do something different, but the closest thing, the non-thread, that's a thread safe array list. That's a thread safe set. Okay, now these blocking queues and blocking decks, what these are is these will wait a set amount of time to try and, so let's say you have an array, you have a deck, okay? You have a deck or a queue that's producing all these different numbers, all right? Now what a blocking queue or a blocking deck will do is it'll wait a set amount of time if it can't access a particular value, or if it can't calculate a particular value, it'll wait a set amount of time until that value is calculated. If it doesn't calculate it in that set amount of time, it goes on to the next one. Okay, that's what a blocking deck and a blocking queue is. Okay, so I'm going to go down here. So we have a concurrent linked queue. Now, what's a queue? A queue is, all right, what's a queue? Someone told you that's a queue. What's the rules of a queue?
You go from the front.
Yeah.
Bring it back.
Exactly. Maybe you want to rephrase that, Kieran. Yeah, your mind, Kieran, in the gutter, in the gutter. So here's your queue. And we have a couple of people in the queue. Okay, that's the start of the queue. That's the end. Okay, so you join at the end and you leave at the start. Yeah? So that's what a queue is. Okay, so now methods of the queue class are exactly the same. So queue integer queue is equal to new concurrent linked queue. Okay, so I am going to add something to these queues. Okay, so queue dot, now you can either use offer. Okay, so it goes into the queue. So that's the first one. Okay, I put in another one. It goes after the 31. Okay, so this goes after 31. Q dot offer. Put in one more, another one. 100. After 45. And you can also go add. Now add does the same thing. Okay. So I'm going to add 10 at the end. So we now see our queue. That's EX4. I don't want to stop. No.
You don't use push, do you know?
No, that's with decks. Yeah. So thanks, Mary. Okay. So there's no push with the queue.
That's the first time we used offer. We used that in the past.
Yeah. No, we used offer before. I remember for something else. I think. Okay. I think. So queues offer. Now we didn't do queues before. Okay. So offer adds it at the end of the queue. Okay. You can only add at the end of the queue. All right. Now, yeah, the deck you can do both. Okay. So you can only add at the end of the queue. Now, you can only leave at the head of the queue. So, put in here, you can only leave at the head of the queue. Now, you should consider using these for queues anywhere you want to queue things up. All right? If you want some sort of, you're queuing up tasks, for instance. Okay, you've got a queue of tasks, right? So you want them to go from the bottom. All right. So you have a set amount of tasks. You want to go from here. You're always guaranteed the order. With lists, you're not guaranteed an order. With sets, you're not guaranteed an order. With tree set, you're only guaranteed order if it implements the comparable interface. A queue guarantees you the order. All right. It's You put them in, they go to the back of the queue. All right? So, now how do you leave a queue? You leave a queue by one of two ways. You can, first one is peak. Now, peak. This only retrieves the value at the head of the queue. Okay, so what's at the head of the queue? What's at the head of the queue is 31. Right? So if I go here, queue dot offer or dot peak, that's going to be 31. Okay, so now there's also this one. Now this is different. Now this might look, it's doing the same thing as the peak. Okay, let me just see this fucking right. Q dot poll, sorry, it's poll. Now, if I print it out, it prints out 31. So it looks like it's retrieving 31 as well, but it does two things. So poll. Okay. Poll retrieves the value, 31, and removes it from queue. Okay. So if I print off the queue again, you can see 31 is gone. Okay. So if we just want to, so poll, again, you imagine you have your queue of tasks. All right. So here's your task, things to do, your to-do list. All right. So let's say this is task 1, task 2, task 3, task 4, and task 5. Okay. So we would set up a looping structure that's going to poll each one of them. That definitely doesn't sound right. Okay. So it would poll that, so it would do task 1, task 2, task 3, task 4, and task 5. So you can have some sort of, and any new tasks that are coming along in here. All right, so your program can manage 5 tasks at a time. Okay, 5 tasks at a time. Now, this queue is thread safe. If it wasn't thread safe, I can't even imagine what's going to go happening. All right. Now, if it's not a thread safe queue, I don't see how it could access these values here. Do you understand what I'm saying? Because it can only access that value anyway. So I'm unsure as to how a thread could access 2, 3, 4, and 5 at the same time as 1. I presume it's possible, but I don't know how you do it. All right, because you can only access that guy. Now, I think where the threading issue would come in is if one thread polls that and another thread tries to poll it at the same time, that can't happen. So I'd imagine that's where the issues could be. Okay, or if 2 threads are polling at the same time, does it poll this one or does it poll the second one? And how does it determine which thread is going to poll the second one? And how does it determine which thread is going to poll the first one if the 2 threads are coming in at the same time? Whereas if you use a concurrent linked queue, there's no problem. The threads are going to access each of those tasks one at a time. Is that okay? Right. Now, we haven't really used queues at all, but they definitely have their usages. If you have any sort of system where things are coming in and going out, offhand, can you think of anywhere in the business world where you could use queues. Any business that you visit absolutely every day that you could use a queue rather than an array list. A shop. Okay. Yeah. Yeah. Anything that requires, so shop. So you take out tin cans of beans, popped out of here. Then you need to take in tin cans of beans in here. All right. So anything with a queue. Now you could use an array list as well, but you could also use a queue. Any sort of stock taking is basically a queue. All right. Now, so Paul retrieves the value and removes it from the queue, so it's gone. All right. Now, that's so concurrent linked queue is a thread safe queue. All right. Next one we're going to do is it's a thread safe deck. Okay. So this is going to be a deck of integers as well. Now this, sorry, I should say its name. This is a concurrent linked deck. Okay, so what is this? So I should put it up here. This is thread safe queue. This is a thread safe deck. Now, what's a deck? A deck can add at, so deck can add at end and beginning, and can remove from end and beginning. Yes. Double-ended queue. That's what it is. Which, that's D-Q-U-E, double-ended queue. D-E-Q. That's what, oh geez, I'm have to realize that myself. Yay. Okay, so a double-ended queue. Sounds like a good night to me. So you can add on both ends, you can take away from both ends, and this is thread safe. All right, so we're going to create one. Deck integer. I'm going to just call it deck. Now we need to import it. Is equal to new concurrent linked deck. And import that. Now, so we are going to add a couple of things to it. All right, so deck dot offer, that's going to put it at the end. So I'm going to put in, well, 12, that's going to start at the very start. Then I go deck dot push, puts it at the start. So I'm going to put in 100. I'm going to put in another offer. This is going to be 45. It's going to be at the end. And this one's going to be at the start. Now, so what I should end up with here is start off 12. Then we push. Push is at the start, sorry. So push puts it at the start. So we're going to have 100 before 12. Offer puts it at the end, which is 45. Push is going to put it at the start. We got 120. So we should get 120, 100, 12, and 45, I think. So I'll just check that. So offer PEQUE. Yep, 1245. Okay, so what does this do? Puts at N at Q of deck. This one puts at start of deck. Puts at end of deck. Puts at start of deck. So we end up with that. Now, we can, this guy, so this would pop, will remove the first item on the list. Okay? Pop will remove the first item on the list. So it'll display it and remove the first item. Now poll will do so all of the methods of the queue are also available to deck. Okay? All of the methods of the queue are also available to deck. So what does pop do? Pop removes, sorry, displays first number and removes from deck. This one here displays last number and removes from deck. So it should display 120 and 45, and then we should be left with just 112. Okay. Right. So pop. Let me have a look at this again now. Retrieves moves the head of the queue, representing the first element in the deck. Pop. Okay, that, oh yeah, they both move from the top. How to remove the last one? Can you remember that? What's that? Huh? That's what it is too. Sorry, you're right. Sir. Offer. No, that's for inserting.
Oh, sorry. Yes. Yes. Oh.
Yeah, poll doesn't do that. Poll last. Yeah. Yeah, it's poll last. It's the only one. Because pop's an element for stack, in other words, removes and returns the first element in the queue. Poll retrieves and removes the head of the queue. That's removing 100. So it's poll last. Okay, so what does that do? Poll last. That removes the last element. So it displays so that should display 45 and we should be left with 112. Yeah. Okay. So you can remove from both ends. So I'll put in here as well. Can remove from both ends. Can add from both ends. Okay. And there's nothing more exotic than that. It's as simple as that. And also, all methods of the queue are also available for deck. Okay, so all the methods of the queue interface are also available to the deck. All right. Now, so they're the simplest forms of. So we've done a concurrent hash map. We've done a concurrent linked queue, and we've done so a concurrent hash map is exactly as it says in the tin. It's a thread safe hash map. A concurrent linked queue is a thread safe queue. A concurrent linked deck is a thread safe deck. Okay, deck means double-ended queue, which I just discovered today. Okay, so deck is a double-ended queue. That means you can add at both ends. All right. Now, so the next one we're going to do is this is going to be that last one, static void ex4. This is static void ex5. Right. So these are blocking queues. All right. Now, which is these two guys up here. So it is a linked blocking queue and a linked blocking deck. Okay. Now, so what are these lads? So blocking classes implement the blocking interfaces. And there are more than these two. And the ones we cover are linked blocking deck and linked blocking QUEUE. Both implement the blocking queue EUE. These are like regular queues, except they are thread safe and also include methods that wait a specific amount of time to complete a particular operation. So we can see that if you have a queue of tasks, now the queue of tasks might take a specific point of time. So if you remember the just go back up here a minute. So just go back to the previous example here. So we're using a new fixed thread pool. Remember, you can also have scheduled threads. So you would have a new scheduled thread pool. Okay, so they allow a certain amount of seconds to do something. Okay, so you can sync up your new scheduled thread pool with your this guy with these blocking queues. Okay, So it's going to wait a set amount of time to complete a particular operation. If it doesn't complete in a particular point of time, you can give it options as well. All right. You can throw an exception, or you can try something else. Okay. Now, so here are the methods. So methods of note are offer. Now it's different to the offer. This is an overloaded offer. Okay. Offer that takes a object, some object. Okay. You could be adding an integer. It could be doing a task, whatever. Okay. So long timeout. And finally, time unit. Now, that means so E is the type of object in your queue. Timeout is the amount of time. Time unit is the unit of time you want to use, i.e. nanoseconds to days. Okay. So you're dealing with these time, you see these time units repeating themselves a lot with threads. Okay. Whenever you see these, the time unit, usually it goes from nanoseconds, and the maximum time unit allowed is usually days. Okay. Is usually days. Now, so what does this offer do? So it adds item to the queue and will wait a specified time if the queue is not ready. Because remember, only one thread can access this queue at a time. All right. So if the thread has to do a lot of work, it might take a bit of time for it to write the value to the queue. Okay. So how long will it wait? The blocking queue will allow us to wait a set amount of time. Okay. If it goes over that set amount of time, if this goes over a set amount of time, this returns false. Okay. So as item queue, and we'll wait specified time if the queue is not ready. If this goes over the set amount of time, this returns false. So this returns a Boolean. Okay. So offer is actually Boolean offer. Okay. So it returns true or false. So returns true if successfully added. Is everyone okay with that? Yes? Okay.
The first operation will always get as much time as it needs to complete. And there's one that's waiting then behind it.
Yeah.
If the first one has
Exactly. Yeah. Exactly, Jason. That's exactly it. Okay. I need to clarify that actually now. Okay. I need to clarify that. So, offer. Now, the other one then is poll, which is long timeout, time unit. Okay. Now, what does poll do? Poll displays the item and removes them. Okay. So, what does this do? This retrieves and removes an item from the queue, waiting the specified time now. This one returns, I don't know why it doesn't return true, so it returns null if time elapses before the item is available. Now, so the ones we're caring about here, because it's a queue, we want to know how to add and take out. That's the two important ones. All right, they're the two important ones we want. Really, that's what a queue is about. You don't necessarily just want to have a look at the end, at the beginning of the queue. You want to take from the end of the queue. You want to add to the end of a queue. That's what you want to do with them. Okay. And by the way, these are blocking. This is the blocking queue is the first one I'm going to show you, not a blocking deck, which is a different thing. All right. Now, put in here, both of these methods can throw a checked exception, which is interrupted exception. So they either have to be thrown by the method or in a try catch block. So we're going to have them in a try catch block. So I create a try catch block. Try catch. Now I can put in the exception, but I put in the actual exception that can be generated, which is INTE RRUPTED EXCEPTIONE. And we import that. Okay, why is that giving me? Okay, I have nothing happening inside here. That makes sense. Okay, I'll take that out for a minute. Right.
Well, we used to import these methods. One of them is four, what's the other one?
Oh, sorry. Yeah, poll, and the other one is offer. So where is it up here? This one here. This one, Kieran. Okay. And this one here. All right. So we are going to, inside here, I am going to go blocking queue integer block queue. Now I need to import that. Now it's equal to new linked blocking queue. I need to import that as well. Now you can use offer. Now this is thread safe. This is a thread safe queue. All right, but it has the additional overloaded offer method that can wait a set amount of time. All right, so I'm going to add a block queue dot offer. I'm going to add the number 39, which is fine. Okay, now I'm going to do another one. So I'm going to put this. Now, offers return true or false. Okay, so if it is inserted correctly, this will return. Yeah, I remember doing this before. Okay, we wondered why it was returning true or false. Okay, so this returns true, as will be inserted. Okay, now we're going to use the other type of offer. So this is going to be block q dot offer. Right, so we're going to have the number 345. Now we're going to wait 4 time unit dot seconds. Now, so what is this going to do? So this will add number 345 to the queue and wait for 4 seconds if necessary for space to become available. Returns false if time elapses before 345 is inserted into the queue. Okay, this will return true. Now, because you could have some sort of system set up where you have multiple threads, and this is a blocking queue, so it's a thread safe queue. So there might be some sort of queuing mechanism going on. You might have to wait. So if it goes more than 4 seconds, if it takes more than 4 seconds to insert the number 345 into our queue, it's going to print false. However, both of these, okay, I'll go back to main, this is EX5. True, okay? So they're both added to the queue, and we'll have a look at them just to check block queue. There they are, 39 and 345. Now I'm going to add 2 more numbers. Okay, I'm going to use this. I'm going to add 100, and I'm going to add 200. So 39, 345, 100, 200. So you can imagine a situation, if that returns true, do something. Okay, so you can do something like this. If if it's inserted, do some code. Okay, so we can check if it's inserted or not. If it's inserted, only if it's inserted will we continue on. If our password is, if the encrypted piece of text that represents your password is written to the database. Hello. Hello. Give me a second there. Hold on there a second. Hold on a second. Hold on.
Yeah. All right. Well, I'm just getting plus from 10. Yeah, I mean, well, is it not? Oh, to walk into town. Well, that doesn't take long to walk. You will walk 20-minute walk, yeah. Oh, yeah, I just walk. Right. I know, I'm glad. I'll just walk in.
All right. So where were we? All right. So blocking cues. Now, so we're back again. So I've added a couple of things to it there. This can.
Notice that would be a link blocking queue. Could you have a blocking queue that was linked?
Well, it has to be something that implements the blocking queue.
Yeah.
So I don't think there's a new blocking queue. Let me just see if there is, Kurt. I don't know. I don't know. We'll see. I'll see. So let me just see. I don't know if there is something called a new block. Well, let's see if there is. No, blocking queue is only an interface. Yeah. So Right. Now, so this is adding it to the end. Now, so you can also remove. So this is going to add at the end of the queue. So if we want to remove at the start of the queue, so it's, remember it's poll, all right? So this will poll, block queue dot poll. Okay, so that will display the first element, which is 39, and remove it from the queue. Okay, so display 39 and remove from queue. Now, there's an overloaded polling. Okay, so it's this one. So it is block queue dot poll. So we're going to wait 4 seconds. Now, I don't know how to actually, I'm trying to think if there's any way I could actually show that. You could, before you remove something from a queue, a set amount of steps has to happen. You could do that, maybe. All right. But what's this going to do? So it retrieves and removes the head of the queue, which by now will be the number 345. Will be the number 345, and will wait for 4 seconds if necessary for the queue to be ready to remove the number. Returns null if the time lapses. Okay.
So what's that? 39.
Sorry?
39. Display 39.
Okay, so see up here, that's the very first element. Okay, so 39, 345, 100, 200, and 345. Okay, so this guy removes 39. This guy removes, will display 345 and remove from queue. Says I, hopefully. There it is, 39 and 345. Now, so a linked blocking deck, okay, is the same as, so that's linked blocking queue. Okay. The next one, so this one, sorry, was linked blocking queue. Should I put it in here? Linked blocking queue. Okay, that's capital L.
No, you're trying to add something or take something
Mhm.
from you, and you give it time there. If it doesn't do it that time, they get hold of the queue to do it.
Yeah.
It just returns false.
Well, so if you're trying to add something,
Yeah.
right, that's going to return false if it's not added.
You want people to look at the false instead of the added.
Yeah. So what you could do is, yeah, time to 4. So if false, don't enter in another one.
False try again with the.
Yeah. Or if false, try with maybe a bite. Or try it with a short. Or drastic, create a new queue and start again afresh.
Or give it enough time.
Or give it more time. Okay? So you can put in whatever you want there. All right? Now, you don't use these guys. So you can have a queue that has tasks in it. In actual fact, that's a very good usage for a queue. It's a queue of tasks. So if a particular task doesn't perform in 4 seconds, issue a warning on the screen. That's an example. Okay? If after 15 seconds it still hasn't done, issue another warning and try maybe the next value. See, will that go in? Or do something, or some mitigating factor. All right?
Can you use conditions other than time?
Say that again now?
Can you use conditions other than time? So can you say if some other thing is completed, then do this?
Well, if your queue could be a queue of methods, could be a queue of lambdas.
Yeah.
So if the lambda hasn't successfully completed,
That's what I'm saying. You
Yeah.
can do that instead of time use.
no,
No. you have to-
not on that one. But what I'm saying is, this guy here, it's an integer here. It could be anything. All right, it could be a task. It could be a thread. So if this is not completed, right? So we could say it's doing something, okay? And let's say, as you said, some condition. If the age is greater than 18, yeah?
Yeah, instead of using time unit though. So you check-
No, the time that's only for waiting for 4 seconds for this to complete.
Yeah, you can't say wait until something else, someone believes or something.
No, but you could do that all inside here.
Okay.
You could have a task, you could have a lambda, you could have a thread, you can have anything there. It could be a queue of tasks, it could be a queue of threads, it could be a queue of functional interfaces, it could be a queue of objects that are doing certain things. And if the object if it doesn't meet all these conditions, you could put the thread to sleep for 100 or let's say for 5 seconds. And if your timeout is set to 4 seconds, that would cause it to fail. Do you get me? So whatever you want, yeah. You can, but if you do that, then it's going to be a queue of objects. And they're going to be very limited because when you have an object reference, that means you can only call the methods of the object class. So they'll be limited. But you can put literally anything in there. It can be threads. It can be tasks. It can be lambdas. It can be anything. Okay? So you could have your, what's the submits again? I'd have to look on it now, but you could have a queue of tasks. Okay? You could have a queue of tasks. And yeah, we might do that tomorrow actually. Okay? I'll create a queue of tasks. Is that okay, Jesse?
Yeah, yeah.
Yeah, I will create a queue of tasks tomorrow to show how we can use them with threads. Okay? Now, when you have a queue of tasks, you need to be careful with them. Now, you can only remove things from the top. Sorry, you can only remove things from the head of the queue. You can only add things at the bottom of the queue. All right? So it sounds like it's thread safe, but it's not, because 2 threads can access the top element at the same time. 2 threads can access the bottom element at the same time. 50 threads can access the bottom element at the one time. 50 threads can access the top element at the one time. So you need to make it thread safe when using tasks. We'll do that tomorrow. Is that okay? I can't really do it on the fly here because I'd have to work it out. But, so can any other condition go in here? No, it's a short answer.
Shouldn't.
But you can accomplish the same thing by if you have a queue of objects and those objects have some internal state. If it doesn't have the internal state, just set the time to greater than that. Put the thread to sleep inside that for longer than 4 seconds. And then it does the exact same thing.
It just makes it.
Yeah. As they say, if you're told in computer programming you can't do something, what they mean is you can't do it directly. You can do absolutely anything indirectly. All right? Like you can't change a final object. No. Directly you can't. Indirectly it's possible. All right?
That's because the offers the
Well, the offers.
it's got time out of that last around
Yeah.
this time instead of
Right. So we can imagine here, right? So we've got a queue of tasks. All right? And each of our tasks is going to take 3 seconds. Okay? 3 seconds. 3 seconds. Now, if anything goes wrong with these tasks, we're going to put our thread to sleep for 4 seconds. Okay? If anything happens inside any of these tasks, we're going to put, let's say, 5 seconds to make it easier. Okay? So you have a queue of tasks. Each of them take 3 seconds. So this time unit here thing is fine. However, if something failed inside it, something, let's say the age is greater than 18, let's say they don't have enough money in their bank account. Okay? Something like that. We could put the thread that's operating on this, we can put it to sleep for 5 seconds. That will cause this timeout thing to click in. All right? And you can put in whatever you want in here then. You can put up an error message saying you have, and also you can have that task set up in such a way that it can fire an error message out as well. Okay, you can fire out an error message, or I could say you do not have enough funds in your account to buy this Ferrari. You have only got 5 pence, whereas a Ferrari cost you 150,000. Okay, so the answer is not directly, Jason, but relatively easy to do it indirectly as well. Okay, so now as far as I know, you can't. That doesn't mean that you can't. Maybe there's some other version of offer that I don't know about. Let me just have a look, see. Let me just see. So I will go block queue to offer and see what comes up. Let me just see. Block queue dot. So add. No. Add all. Have a look at offer. No, there only seems to be one of them, Jason. Now, that doesn't mean there isn't some other obscure class that does that as well. There probably is, I don't know. But I don't see one there. Or you could also just go, if the certain object doesn't meet the conditions, don't put it in. So there's, there's several different ways to skin the cat. Okay. Now, so that is a linked blocking queue. So the next one is, roll off your tongue. This is a linked blocking deck. Okay. So what is this one? As this class extends both queue and deck, all the methods of those classes are also available to this. Now, it also has the and also, let me just check something up here. So linked blocking deck, yep. So, and also all of the methods of the linked blocking queue. Okay, so now this is a double-ended queue. So that means you can add on both ends of the queue, you can take away from both ends of the queue. Okay, and you can do timeouts for both of those operations. All right, so, and just like before, when you're adding or you're taking away from, if you're adding or taking away to a deck, it can generate an interrupted exception, which is a checked exception, which means it has to be inside the try-catch block. All right, so the term is blocking deck integer block deck.
So, since there's been, you said also the methods of it, link blocking, is that deck?
Q.
Or Q.
Q. See this one here? Or sorry, or the blocking queue. Blocking queue. Okay. All right. Now, so blocking deck. So import.
Just deck, no, because of just deck, distinct Q.
It does.
Darwin deck.
Yeah, it does. It does. So all the methods of the queue are also available to deck. Yeah, there. Okay. So is equal to new linked blocking deck. So we can have a look at the deck previous. So we can go block deck dot offer 34. Okay, so that's going to insert at end of queue. Block deck dot push puts it to the start of the queue. Now, both of those can use the version that's going to use a timeout. So I go block deck dot offer. So we can see integer e long timeout. So that's, we're going to put in the number 120. We're going to wait a maximum of 4. And we're going to make it this time unit dot milliseconds, which is 1,000 of a second. And I go block deck offer push, and I'm going to put in 345. I'm going to put in 4. I'm going to say time unit dot. This is going to wait 4 minutes. Okay, you can't do a push. Let's see. Okay, so there isn't a push blocking version. Okay, so there isn't a push. So what you could do is push puts it at the start of the queue. Let's see what else is available. Offer first. Okay, so there is an offer first version. So that will go at the very start. I'm going to put in 3. I'm going to say time unit dot microseconds. I don't know what a microsecond is. I presume that's a 0.1 of a second. Okay, so there isn't a, so no overloaded push method, but there is an offer first. Okay, so that should put that 34, 50 should go at the start, 20 goes at the end, 2, 3, 4 goes at the start. So we should end up with E, E, Q, 2, 3, 4, 50, 34, 120. Okay, so offer is at the end of queue of deck, and this is going to be start of deck.
Oh, there's not the last.
Sorry?
After last. There's no readable with offer.
What's the same thing as offer then?
Exactly the same thing, yeah.
Okay, so I can put that in as well. So block deck dot offer last 56 timeout 4. I'm going to say time unit dot minutes. Okay, so that's the end of the deck. So you can, I'll just copy these. I have them already done, so forget. So this is block deck. And the last one. So this will remove the first one. This will remove the first one and it'll wait 950 milliseconds if it has to. This removes the first pole first again. This will remove the last one. All right, so you end up with oops. $120 just. Okay. So decks, queues, blocking deck, blocking queue. The only difference from an ordinary queue and an ordinary deck is that you can wait a set amount of time and they're thread safe. Okay. So that's the only difference between a blocking deck and a deck and a blocking queue and a queue. You can wait a set amount of time and they're thread safe, most importantly. Any questions on that? Nope. Okay. Yes, Kim?
When you got push 15,
Yeah.
there's no overload method, but it's still kind of synchronizes with it.
Oh, it does, yeah. All of the methods of these classes are synchronized. Okay, so everything is synchronized. All of these they're synchronized collection objects. So Number one, the first thing is that they're thread safe. And you've stuff like blocked and queued, then it's going to wait a set amount of time before something happens. Okay? So they could be synced up to your threads, your scheduled thread pool. 10 scheduled thread pool. They're going to have a 2-second interval in each one of them. You could set the time intervals 2 seconds in each one of these as well. So they'll sync up perfectly. All right. Now, so they are blocking queues. Now, the next ones. Now, these are you can. Now, the problem with that is that the collections are atomic. Their methods are not synchronized. So that's going to be the problem. So the objects themselves are atomic, but their methods are not, as far as I know. Okay. That's why you have these things, because if it was the case that you could make your collections atomic, then you wouldn't need all of these things. Okay. As far as I know, it's just making the actual object thread safe, but the methods are not thread safe, and that can cause. I won't even begin to think how they'd even work, all right? Because it would get woefully complicated. All right. Now, so static void EX6. So these guys, these are called skip lists. Now, I don't know why they're called skip lists, because what skip lists are, they're thread safe versions of tree sets and tree maps. I don't know why they're called skip lists. Who knows? Okay. They really should be called something tree or something like that. They're called skip lists, right? So, so I'll put them down here. These are concurrent skip set and concurrent skip list. Map are concurrent thread safe versions of tree set and tree map. Okay, so what's about tree sets and tree maps? Tree sets only allow values that have a natural order or implement comparable interface. Okay, now in actual fact, tree sets only allow values that implement comparable interface or uses a comparator. Now, I've forgotten what comparators are myself. Fuck it, there's a lot from this shit. Right? So I need to have a look back and see what a fucking comparator is. I know it's a separate object you use to organize a tree set. All right? I know what a comparable is. So I'm going to show you what a comparable is. So well, first of all, I'm going to create let's say a ordinary tree set. Tree set T, so T int is equal to new tree set and oh yeah, we'll only allow objects. Okay, all collection objects only allow objects. Okay, or use as a comparator. All right. Now, so integer class implements the comparable interface. All right. So you can add integers to it. So I got T int dot add. I'm going to add 1,200. I'm going to add the number 50. I'm going to add the number 12. I'm going to add the number 100. Now, if I print them out, we can see that, oops, sorry, EX6. Now, I don't have it done out, but we'll have to do it as well. We're going to have to start using all of these different collections with threads to see how they work. All right. We haven't used them with threads so far, and I don't have examples done out, but we have to use them with threads to show that they are thread safe. Okay. So, tree set only allows objects that implement the comparable interface. All right. Now I'm just going to quickly create a class here. I'm going to call it human. All right. I'm not going to have anything in it. Now, integer implements the comparable interface. All right. That means you can add it to it. Now, what it does is it organizes them in the order that the comparable the compare to method inside the integer class has. Now, the compare to method, what it does is it puts the lowest numbers first. Okay. Now, a tree map. Do you remember a tree map? So if you attempt to add anything that doesn't implement the comparable interface to a tree set, it would not work. So if I go tree set, human, and I'm going to say human tree is equal to new tree set. Now, that doesn't produce an error. If I attempt to add a human to it, okay, so that gives us a class cast exception. All right, now, because the human class does not implement the comparable interface. Now, you might ask then, well, why does it allow us to create a tree set of type human? Because one of the subclasses of human might implement comparable. Okay, so human does not implement comparable. So a human cannot be added to a tree set. However, you can create a tree set of humans as a subclass of human could implement a comparable interface. Okay, so this causes no error. No exception. Now, this causes a class cast exception. So, a concurrent skip set is a thread-safe version of a tree set. Okay. Now, you can have a tree set of humans, but you can't add a human to a tree set because the human class itself does not implement the comparable interface. Now, we are going to create classes that implement. Now, I have to go over all of this before we go on to the concurrent skip set because it's a while since we've done tree sets and tree maps. Okay, so I'm going to go to the, let me just see which one I have here. I'm going to go to the duck class. Now, we have a duck, and the duck only has a name, nothing else. Okay, and duck string name. This dot name is equal to name. Okay, now I wanted to implement comparable. Now, so this means it's going to implement the methods of the comparable interface. There's only one, compare to. Now I'll give it a generic type. That means when I add the unimplemented compare to method, hold on a minute now. All right, take out this guy. I'll do that again. In the wrong place. Give me a second. Go away. Piss off. Fuck. All right. So, what the fuck is that coming up there for? Come on, go away. All right. String name, duck, string name, is dot name equal to name, and increments comparable duck. So I'll go here, add unimplemented methods. Okay, there we are. Now, so the compare to method returns an integer. All right. Now, the way it goes at numbers, so I am going to use the compare to method. So I'm going to call this duck D. Okay. So I'm going to return name dot compare to D dot name. Now, what we're using there is we're using the string class compare to method. All right. Now, what the string class compare to method does is it organizes strings in alphabetical order. So if the name of the duck that's calling this method, if its name comes alphabetically before the duck it's comparing to, it'll go first in the list. Okay, so we can put these ducks in a tree set. So if I go here, yeah, sorry, Kieran. Okay, so this is using the compare to method of the string class to organize the ducks by name alphabetically. Okay, return name dot compare to D. So we're going to compare one duck with another duck. All right, I'm going to go back to here. So I am going to do I am going to create a tree set. I'm going to create a couple of ducks. Duck Anthony. Ent is equal to new duck Ent. Okay, duck Z is equal to new duck Z. Last up, duck Bert is equal to new duck Bert. Okay, now I'm going to do a tree set. This is going to be a tree set of ducks. I'm going to call it duck tree. Is equal to new tree set. Go inside here. Arrays dot as list. I'm going to say ent z and Bert. Now, these ducks should be organized ent z Bert. Okay, I don't have a toString method inside the duck class, so I need to change that. So I just go source, generate toString. I want to print off the name. Now I'm going to print off this tree set of ducks. Ent, Bert, and Z. Okay. Now that's just a basic explanation of tree sets. And hash maps, then it's the value that has to implement the comparable interface, which we will do tomorrow. Now, as well, tomorrow, I want you to, you can have a one-page document or out or two-page document or whatever, telling me what you learned about Azure, your area of Azure that I give you to look at. Okay. You can present it to the class if you want to, or you can give it to me and I can present it to the class, whatever way you want to do it. Okay. So we all got an area. So I don't want the Encyclopedia Britannica about it. I just want explanation of what it is, what it does, what we need to do to get it working. That's it. Okay. If you haven't found out how to work it, that's fine too. Okay. Or if you decide it's not relevant, that's also fine. Okay. Now I'm going to stop the share.
Well, did you get a card for me?
Have you not logged on to the one there?
I'm not try it. What address actually?
I don't know. You were supposed to log on a week ago, Roland. I gave it to you a week ago. Whatever it was a week ago. I can't.
Yeah, but actually it was one account for two of us.
Yeah, but I got you another one. Do you remember it? I can't remember what I got you. Can you remember what it was?
No, but yes, I remember.
Yeah, okay. Not the same now as Igor's. It was another one.
No, a new one.
Yeah, you have it. As long as you have it, man. And I'm going to send an email to Joe and say you all need letters because you want to claim for a student card grant. So I'll stop.